Okay, so let's finish this up here with our XY table. So if I substitute 0 in for x, that gives me 6 times 0, which is 0. If I substitute 1 in for x, that gives me 6 times 1, which is 6. If I substitute 2 in for x, that gives me 6 times 2, which is 12. And if I put 3 in for x, that gives me 6 times 3, which is 18. I'm going to go ahead and erase all this work so I can label my scale, because I can count by ones on my x-axis, but I'm going to have to count by threes on my y-axis so that I can fit this data on the graph given to me. So my first point, 0, 0, is at the origin. My second point, 1, 6, I'm going to go over 1 and up 6. My third point, I'm going to go over 2 and up 12. And my third point, I'm going to go over 3 and up 18. So as I look at this, I can see from my graph that this is a proportional relationship because it graphs a straight line and it passes through the origin. I can see that in my table, I have a 6-to-1 ratio each time. These all reduce to 6-to-1. And as I look at this equation, I can see that y equals a constant multiple of x. Y is always going to be 6 times as big as x. So this is going to be proportional, and I've proved it all 3 ways. So y is 6 times as large as x, which is the definition of a proportional relationship when y is a constant multiple. So does the equation y equals 4x plus 1 show a proportional relationship between x and y? So let's think about in a table here. I think that's the easiest, quickest way to think about this. So again, if I just look at 0, 1, 2, and 3, if I put 0 in here for x, then I have 4 times 0, which is 0, plus 1, which is 1. If I put 1 in for x, I have 4 times 1, which is 4, plus 1, which is 5. If I put 2 in for x, 4 times 2 is 8, plus 1 is 9. And if I put 3 in for x, 4 times 3 is 12, plus 1 is 13. So as I look for a constant ratio, I have a 1 to 0 ratio, I have a 5 to 1 ratio, I have a 9 to 2, and I have a 13 to 3 ratio. None of these is equivalent to any of the others. So I have a different y to x ratio each time, which means that y is not proportional to x. And here's why. Anytime I am adding on to my x term, it's no longer proportional. It's no longer a constant multiple of x because y is a constant multiple of x plus 1. So that throws off our proportional relationship. It still graphs a straight line, but it's just not proportional because it won't go through the origin. All right, so let's check out this proportional relationship between time and the distance run by a cheetah. So part A, what does the point 190 represent? So on my graph, I'm going to start at the origin. I'm going over 1 and up 90. So this tells me that the cheetah is running 90 feet per 1 second because time on my x-axis is measured in seconds. What do we call it anytime we have a rate with a denominator of 1? I hope that you are shouting out unit rate right now. This is my unit rate. My unit rate on the graph is always where x is 1 because my y to x ratio will look like this on my graph. So 90 feet per second is my unit rate. On part B, what does the point 0, 0 represent? This is the origin, and this is the cheetah's distance and time at 0 seconds. So he's gone 0 feet in 0 seconds. That's what this point represents, is before he has begun running. On part C, how far did the cheetah run in 3 seconds? Well, seconds is measurement of time. It's on my x-axis. So when x equals 3, the matching y value on my graph is 270. So the cheetah can run 270 feet in 3 seconds. Now we can also use graphs to make predictions. So assuming the cheetah continues to run at the same speed, we can see a constant rate here. How long would it take the cheetah to run 900 feet? All right, so my graph stops here at 450 feet. And it took him 5 seconds to run 450 feet. But because I know that 450 is half of 900, if he maintained the speed and he ran 450 feet in 5 seconds, then I know he could run 900 feet in 10 seconds. Because I can do my y to x ratio to help me figure that out. So I know that to turn 450 into 900, I would multiply by 2. Whatever I do on top of a proportion, I have to do to the bottom. So that gives me 10 seconds. All right, your turn to check it out. Feel free to pause the video and test your knowledge. We have a proportional relationship between the amount of nuts and dried fruit in a trail mix. It's making me hungry. So you want to know how many pounds of dried fruit there are per pound of nuts. We want to know what point represents this unit rate. If it's a unit rate, I want pounds of fruit per 1 pound of nuts. So that means on my x-axis here, which is measuring the pounds of nuts, I am looking for 1. So I find the point on my graph that matches that. And when there's 1 pound of nuts, there are 2 pounds of fruits. So this point would be 1, 2. All right, you are ready to check out your Digits 8.1, 8.2 homework. You'll do great.